Here's going to be the code walkthrough for a simple ARM assembly program that will demonstrate pulse width modulation on the Raspberry Pi. I'll just begin by briefly discussing what pulse width modulation is. Pretty much it's a process that we'll use to control the average current and voltage being sent to any load just by switching it very quickly between on and off states. You can use this for like transmitting data. Things like Li-Fi will do this, or reducing energy consumption. Like if you just reduce the total current being sent to it, obviously you'll use less energy. For this purpose anyways, I'll be using it to control the brightness of an LED. Normally if you tried to achieve a dimming effect, which is what we're going for on a regular incandescent light bulb, you could achieve this just by sending less current to it, and as a result the filament would burn less brightly. However, for LEDs it's a bit more difficult. They're not analog, their controller is digital, so they can only be in two distinct states, on and off. So however, we can still achieve a dimming effect by turning it, like I said, very quickly using pulse width modulation between on and off. And the human eye can't see these very quick fluctuations. We'll be turning on and off thousands of times a second. So we just see that the total light output is less, and therefore we perceive the LED as dimmer. And last thing before we get started into the code, I just want to discuss the concept of duty cycle. This is simply the percentage of the time the load is receiving a current. As for the LED, as the duty cycle decreases, it's receiving the current a smaller percent of the time, and we'll see it as dimmer. I might just use this term as I'm discussing the code. So I'll just hop right into it. All of this right here, this is just taken from the Baking Pi tutorials from Cambridge University. Pretty much I'm just going to be right here loading this is the GPIO address on the Raspberry Pi into this register, and all this down through here is just going to really just be helping me turn the LED on and off. And sorry, including up to here. I will be using registers 7, 8, and 9 to be controlling this pulse width modulation. And just to let you know, maybe you can see it as I'm walking through the code, I created a breathing effect. It's, the LEDs will dim and then become brighter, just on and off. And yeah, you see this kind of effect in like, gaming keyboards come to mind when they get dimmer and brighter. Alright, so we'll just hop right into the code. So this outer loop section, all that I run in here is just, once the loop is done, I'll just reset these variables so it can continue breathing. So we get into this first inner loop. Very first thing I do is turn on the LED, and then I'll turn. This is my delay. It's doing a call out to an external file to this wait function, which was also from the Baking Pi tutorials. But this is going to delay for however long the on delay is set, which right now it's set to this value, and it is, see, 10 times larger than the off delay. So the LED starts off bright. So once it's delayed for that relatively long amount of time, it's going to turn the LED off and delay for a relatively short amount of time the off delay. This is just the bottom of the loop. We're just going to update, make the on delay smaller and the off delay larger. So this over time will help us make the LED brighter with each iteration of this loop. This is the last thing, is just the exit condition. If the off delay gets to be larger than this value right here, we're just going to hop to the second inner loop, which will be the reverse of the first inner loop, which dims the LED. It will make the LED brighter, and otherwise just jump back up to the inner loop. So this will continually make it dimmer, and then with this second part of the inner loop, it just reverses the process. You see the only lines that are different are these right here. Instead of subtracting 1 from R7 and making it smaller, we're just making it bigger, and same, but the opposite goes for R8. And again, we're just going to compare if R7 is bigger than what it started off to be. If that's the case, we're going to jump back to the outer loop, reset our variables, and continue the process. So that's pretty much it. Again, it's just relatively simple code. But if you want to see this code running, I posted a video in the same blog post where you can see its execution. Unfortunately not very well because I'm filming it off a phone camera, but you can still see the breathing effect. But anyways, thank you for watching.